And so for our next talk, we're really happy to have Harish Srinivas. He is at Meta. He'll be calling in online to tell us all about some important new changes to Executorch and how they can have quite profound ramifications for federated learning, because it can start to expand the footprint of mobile devices that can finally start to do on-device training and therefore participate in federated systems. He's actually been quite a pioneer in federated learning himself, working on the Papaya system earlier. And so I'm fascinated to see what Harish and his colleague is going to tell us about.
Hey guys, hopefully you are seeing the screen of the slide share, and I'm not able to see the full video, but hopefully all of this is set up correct. If so, yeah, cool. Thanks Nick for the intro. I'm Harish, software engineer in the PyTorch Edge team, or the Executorch team, working on federated learning at Meta. And I have my colleague Jacob, who is part of the Executorch runtime team, and he'll be giving an intro about Executorch, and I'll be following up with the training and the federated learning aspects of it. Jacob.
Yeah, can you go to the next slide? Yeah, so like Harish said, I'm here to talk about Executorch. So Executorch is kind of the solution from PyTorch for running your various ML models on the edge. One thing I'll say is that PyTorch tends to think of the edge as a lot more restricted than kind of people in the open source community might. So when we say edge, we're talking about kind of the far edge, so ranging from mobile phones is kind of the most resource rich environment, down to embedded DSPs or something in a headset or other kind of devices. So our previous solution was PyTorch Mobile, but that's mostly deprecated, and we're all about Executorch now. Yeah, so the general kind of problem statement is most researchers and model developers start with a PyTorch program in Python, and then they want to figure out how they can get that model to their edge devices and run it performantly, and potentially even start training it. So the general way we think about this is you have your eager PyTorch model, and then you run it through an exporting type system where you give it some inputs, and we try to convert it into an exported graph of nodes, right? Of calling one operator into another operator, or maybe some control flow as well. And then we take that graph, and you can run all sorts of user passes on it, like reordering nodes or fusing nodes, things like this, to gather better performance guarantees. And then we take that graph and we convert it into a sequence of execution instructions, an execution plan, so that you can run it on device. And then we convert that into a binary that we can then ship around. So one benefit of Executorch over the old system is that it's export-based, which is a first-class citizen in the PyTorch ecosystem. You can take your model, and it's the same kind. It's a very similar flow to torch.compile, though there's no Python backend if there's a graph break. And you can capture a wide range of dynamism, from loops and branching if statements to shape dynamism for batch sizes and things like this. There's a standardized smaller set of operators. So regular PyTorch, I think, has around 3,000 plus operators, which makes it really hard for the various backends on the far edge to kind of integrate, right? Qualcomm would have to go and implement 3,000 operators. Apple would have to go implement 3,000. So we restrict it down to 300 through decompositions and replacements, while still remaining numerical consistency. And then the APIs and your models are the same, essentially, between authoring in Python to running in C++. You're still dealing with module type things. You're still running them. So, another benefit is that you stay within the PyTorch ecosystem completely. You don't ever have to go out. The delegation and lowering processes are very consistent contracts. We have native debugging and profiling built in, so you don't have to try to fire up third-party solutions. And then you can progressively lower, step by step, to get all the way down. Another benefit is it's really modular. You can kind of pick and choose for your solution based on what you want to deploy to. So I think the next slide maybe shows this a little better. Yeah. So you can pick like, oh, if you want to quantize your model, how you want to quantize it. Then you can decide which accelerator you want to go to, be it like CoreML on Apple or a Qualcomm accelerator. You can write your own custom passes on the graph to fuse and mess with nodes. You can write your own custom memory planning. It makes it all very customizable to whatever sort of hardware you see in your particular kind of edge instance. And then another benefit is that because of this modularity, it's really easy for us to go and partner with lots of third parties, such as Apple, ARM, and Qualcomm, where they provide kind of industry-leading performance on their hardware, and you often just get it for free using Executorch. You can just say like to backend Apple or whatever, and we'll just naturally pass over your graph, select sections of it to delegate to Apple's accelerators, and then you just get it for free. Yeah. The other advantage of PyTorch is that it ditches a lot of heavy dependencies that come with the full libtorch package on PyTorch. So our core runtime is only 50 kilobytes in size. We don't have any dynamic memory allocations, no malloc, no atomics within the core runtime. So you can deploy this on all sorts of bare metal applications. Yeah. And so now I'll pass it to Harish to talk about training some.
Cool. Yeah, thanks, Jacob. So Executorch began as an inference-only framework, and we have currently added the training support, like very similar to like inference, like where we capture instead of the forwards pass, like we capture forwards and backwards the entire graph ahead of time, and then like every other step is the same, right? Like it's composable with the existing Executorch workflows and the different backends as well. So right now it works for a handful of models. It is open source, so you can go and like check out the repo. Like it works on XOR, CFAR. Like we also tried it with LLM LoRa training on like smaller kind of the smaller LLMs. So like it is there. It's in the preview or experimental stage at this point, and yeah, we have a lot of ongoing work, like especially around improving the coverage of models, improving their performance. All of this is planned and like upcoming. So just stepping back a bit, before I talk about the ecosystem and federated learning and like how all of that kind of ties in, like what we are seeing is that we see an emergence of AI use cases, right? Like expanding from the server to edge use cases, and like this translates to real opportunities from the use case perspective, like with the data being generated at the edge and consumed at the edge, right? Like as most of the other talks have also alluded to, like you can do offline. It works with offline environments. Like obviously, like there are like privacy and personalization benefits with data all being on the user's kind of local device. Like you can potentially have new experiences that is possible only in this particular environment. Of course, there are, on the other hand, we have hurdles and challenges when deploying these models on the edge, namely the biggest ones being and the resource constraints themselves, right? Like power restrictions, memory restrictions, even thermal restrictions, like where you don't want the phone or your wearable to heat up, like as you are kind of using them. And the other things are like these are heterogeneous set of hardwares. And finally, like debugging and is hard, right? Like especially in the federated setting when you don't have access to all of this data, and like you're also concerned with privacy. Debugging is very hard, and especially when you are talking about device deployments with longer release cycles. And for an on-device training kind of system, like I want to, the main takeaway here that I want to share is that there is more than just the training capability itself, right? Like first, one would need an on-device storage kind of system to collect the data, have feature engineering capabilities to prepare the training and like eval data sets. This needs to be present on the device. Like you will need scheduling capabilities that is resource aware. One needs a way to like say, okay, like hey, start this training job only when the device is idle, connected to Wi-Fi power, and like this these restrictions will also change during the part of the run, so you will need to be able to stop and like resume kind of runs. Like you will need to have this capability. And finally, one needs some server communication channel, especially with the orchestrating server, to download models, upload model weights, or any other kind of artifacts. Again, these are not an exhaustive set of capabilities, but I'm just saying like there is a lot more that needs to be built out for there to be a fully fledged on-device training system on the device. Like this is a kind of continuing the ecosystem. This is kind of the federated learning system at a glance at kind of Meta. The previous slide talked about like all of the client side kind of bits. Like as this group might be very familiar with, like there are like a bunch of server side components that will also need to be built out, from assigning clients to tasks, aggregating model weights, etc. One thing I wanted to also like point out here is that like we rely on a trusted, secure aggregator hosted on secure environments to aggregate all of the model weights so that only the aggregated model weights are observable by the orchestrating server. So I also linked the systems paper for more reference here. Yeah, like just again at a very high level, don't without going into too much of the details, like the federated system at Meta like is focused on the cross-device setup, right? Like it's that's where our focus is, and as a result, we have designed for one heterogeneous set of devices with limited resources and unreliable connection to the server, right? Like they can drop in and like drop out of the protocol at any given point in time. There are two flavors of FL algorithms, broadly speaking. Like one is sync and like async. Async, like sync is the standard, and like async is where like straggling clients can still contribute to the different model weights. Async definitely has better system properties and leads to a faster convergence in practice as in our kind of result. And like finally, like we also aim to provide defendable privacy guarantees, relying on trusted execution environments and differential privacy. There's a final this one. So as a continuation of the effort, like we also see the need for doing federated computations beyond federated learning itself, like such as federated analytics to understand feature distributions and like help with more of the privacy preserving work that is required. So again, like we have a systems paper that I have linked here, like which goes about like, okay, like what the differences are and like how we are seeing it. But yeah, thanks.
There's a hand right in the middle that went up extremely fast. Let's take that question. Jason, to you. Yeah.
Hi. I was just wondering, how does Executorch compare to other offerings such as Onyx Runtime? Is it mainly focusing on the extreme low size, weight, and power deployment options?
Yeah, I can take this one. I think in a lot of cases, our integrations with other backends typically lead to faster performance. But the bigger kind of benefit, I think, compared to Onyx, is the pain point we've often seen internally and certainly in industry is the Onyx conversion scripts often fail in ways that are like hard to resolve and things like this. Whereas with Executorch and with really all of PyTorch 2.0, you get kind of this lowering property without having to leave the PyTorch ecosystem. And typically we found that like exporting is significantly faster and easier for model developers to do than conversion.
I think there was one more question just next to the person. Did you have a question?
Hi, thank you for the talk. My question is about using federated learning. Which platform you are using?
You mean like which devices like these are running on? These are mobile phones primarily, like iOS and Android.
I was interested to know that are you having a collaboration with Flower or?
We are definitely in talks on like a collaboration and like figure out how to work jointly here.
Great. We'd love to talk more. Thank you so much. Yeah. Well, honestly, Executorch is doing exactly what the ecosystem needs, and so we obviously want to help proliferate, and accelerate what you're doing there. So it's great. We're actually running out of time, so thank you. I really appreciate both of you finding the time in your day to talk to us. So thank you very much.
Thank you, Nick.